Okay, when you're asked to solve a quadratic equation, you're being asked to look at some equation that's got its highest power is a 2, and maybe it's equal to 0, maybe it's equal to something else, whatever it is. Your job is to find out what number do you put in for x in order to make the thing true. Okay, that's all that solving is. And when we were doing this thing earlier, we looked at graphing briefly, but the last video you were taking square roots, and we had some real good techniques for doing that. Well, what we're going to do now is switch over to a technique called factoring. Okay, so we've done the first two here. We're going to look at factoring now, and this method works nicely. It doesn't work always, okay, but when it does work, it's pretty handy. Okay, so we'll go on with some of these other methods as we keep going here, but for right now, we're going to stop and look at factoring, and we're going to use quadratic equations that I know can be solved using factoring. Okay, and here's the deal. We have spent some time before taking statements like this and breaking them up into statements like that. Okay, we did some practice on that earlier. You can find videos on it. I might even have a couple of videos around. Here's the idea. We know that when it's all said and done, when we start multiplying these two things back together, we have to get to this. And what we're going to figure is that right there in both places has to be an x, because the only way you could get an x squared when you multiply them is to have an x there and an x there. Okay. The other thing is this. Whatever numbers you see there and there have to multiply to get 9. Okay. Now, you got some options here. That could be 1 and 9. Oops, 1 and 9. Could be 3 and 3, or it could be -1 and -9 and -3 and -3. There are a couple different options. But the other thing, though, is this. When you do this remultiplication, some people call it foiling because you do the first pair, outside pair, inside pair, and last. When you remultiply those, whatever number you've got here times x and whatever number you've got here times x has to add together to get -10x. Okay, so if you happen to use, say, 3 right here, and they were positive, then when you multiply them together, you get +6. Well, maybe we could fix that by making it -3. Okay, that gets you -6. So what we learned eventually was this. The numbers that go here at the end multiply together to get 9, and they add together to get -10. So what pair of numbers here adds together to get 10? Well, 1 and 9. Okay, and the only way they can add together to get -10 is if they're both negative. Okay, so here's the deal. We've taken this statement right here, and we're going to write it this way. X minus 1, x minus 9 equals 0. Okay, now, you may have seen this before, maybe on one of my videos. Here's the idea. I want you to think about this statement here and this statement here. Okay? We'd all agree that the two things, the thing highlighted in purple and the thing highlighted in yellow, have to multiply together to get 0. Well, in a previous video, I had you practice. Find me a pair of numbers that multiplies together to get 0. And every pair that you use is going to have a 0. Okay, so maybe 0 and 5, or 10 and 0, or -16 and 0. You've got to use a 0. So here's the deal. Because these two things multiply together to get 0, either the purple one is 0, or the yellow one is 0. Okay, it's the only way it could work. Okay, if the purple one is 0, then x must equal, oops, try again. Okay, then x must equal 1, because 1 minus 1 would get you 0. Okay, if the yellow one is 0, then x must equal 9, because the only way you could make this thing 0 would be put a 9 right there. 9 minus 9 is 0. So now we've solved this quadratic equation. We factored it, and then we said, what do I have to put into this to make it 0? What do I have to put into that to make it 0? So let's do another one. Okay. Oh, well, that one's kind of messy. You notice that it doesn't equal 0. And the only way for this thing to work using factoring is for it to equal 0. So we're not stuck. We just need to, get this thing equal to 0 first. So we'll just say, here, change colors, add 3 right there, and add 3 right there, and voila, now it's 0. So now, whoops, now x squared plus 11x plus 18 equals 0. Cool. Now we can factor this thing out. That's got to be an x there and an x there. It's the only way to get x squared. The two numbers over here have to multiply together to get 18. So it's either 1 and 18, or 2 and 9, or 3 and 6. Okay. Well, which pair adds together to get 11? 2 and 9. So we'll put a 2 and a 9 there. Because they have to add together to get 11, or positive 11x, we'll make them positive 2 and positive 9. Okay, and of course still equals 0. So now, how do you make this thing equal to 0? Make sure x is negative 2. How do you make this thing equal to 0? Make sure x is negative 9. So x is negative 2 and negative 9. By the way, when you're working with these things in Delta Math, you'll get these two answers. If you type in negative 2 and then a comma, it creates a new box for you to type the negative 9 in. Okay. So let's keep going here. This one, once again, that's not equal to 0, so no problem. We'll just take care of that problem by subtracting x from each side. And I get x squared. X minus x is nothing, so negative 9, or you get negative 9 equals 0. Okay. So you could either go through and factor this thing and look for a pair of numbers that multiplies together to get 9 and adds together to get 0, or you could remember that when you have a difference of squares, you always end up with the square root of that number there, and then one of them is positive and one's negative. So whichever method works for you, factoring it out the way we did before, or remembering the difference of squares idea. Okay? But either way, now we know that x could equal negative 3 from here and 3 from there. Now you got your solutions. Okay? Let's look at another. Well, this one's even messier, but I think we can deal with that. We'll just say, look, if I add 6x to each side, it's going to get rid of that negative 6x. So I'll add 6x right here. And while I'm at it, I'm going to subtract 5 from each side because I've got a plus 5 here and I want 0. So now let's clean this thing up. X squared minus 5x, that's 0, and so is all this. Okay, so I ended up with x squared minus 5x. You could look at this one and say, hey, the two numbers here have to multiply together to get 0 because there's nothing here, and they have to add together to get negative 5. So what would that be? Well, negative 5 and 0 multiplies together to get 0 and adds together to get negative 5. And so x could equal 5 or x could equal 0. Okay? Another way you could go about that, if you're right here at this spot, x squared minus 5x equals 0, is to say, look, you can factor it out this way by just factoring an x out of each term. That's got an x you can divide out, that's got an x you can divide out, and then once again you can see x could equal 0 or x could equal 5. Okay, so let's see what else we've got here. Here we've got one that's already a perfect square. I'm sorry, not a perfect square, a difference of squares. So I'm just going to use the fact that I know how to factor this thing right quick. You get x's here because that's the square root of this. You get 5 here because that's the square root of that. One of them's positive, one of them's negative, and so now I've got it factored. And x could either equal negative 5 or positive 5. Okay? By the way, another way you could approach that problem would be to say, look, go from here to here. X squared equals 25, and then you know that the square roots of 25 are 5 and negative 5. Okay, so this one works the same way as one of the previous ones here. If I just factor that x out, I get to here, and then x could either equal 0 or it could equal negative 9. Okay, so when we're looking at these things, yes, you could have the ones that factor out to things that are uglier like this. Okay, that'd be a pretty ugly quadratic equation. We could multiply that out if we wanted to here. That'd be 15x squared. Let's see, negative 35 and minus 6 at negative 41x, and then plus 14. So we could start with this quadratic equation and factor it. But honestly, there's going to be a method we'll use later that would make this one a little easier. So for this year, when kind of things are a little bit weird, I'm not even going to have you worry about trying to factor ones that have anything other than just plain x squared as the squared term. Okay? So don't even worry about trying to figure out how to solve something like this. If you're interested, in this case, x would equal 2/5, or x could equal 3/7, and those are your solutions. Okay, so that's how you can use factoring to solve quadratic equations.